Let's go ahead and get started here. Let's keep it quiet for this, okay?
Yes, sir.
Now we're in chapter 4.2. We're looking at angle measures for triangles. Okay? Now, what I did first of all, the section in your book, it's headed angle measures of triangles. I went ahead and used some geometry shorthand. This is really what I want you to get used to seeing. And reading this just like it was that. Angle measures of triangles. Okay? Now, what we have here in theorem 4.1 is basically this. The sum of the measures of the three angles of a triangle equals to 180 degrees, okay? Now, the way we're going to basically establish that proof, okay? I want you to pay close attention, is I want you to envision two parallel lines. What I want to do is I'm going to just draw a triangle, draw two lines to create a triangle shape in between both parallel lines. It really doesn't matter how you draw the lines, except that I just want the two lines to meet in a point to form a vertex of what's going to become one of the angles of our triangle in between the two lines. Now imagine each one of these sides actually is contained within a transversal that cuts across those parallel lines, okay? So you've got a transversal here and one here, okay? Now if that's the case, first of all, we know that these three angles here, we'll call this angle 1, angle 2, and angle 3. What angle measure are they going to, what angle sum are those three going to add up to? 180 degrees. So they form all three together, you know, the straight angle. Now I know in regards to angle 2, if I decide to call, let's say, this angle, in angle 2, by the way, we look at angle 1. We're not thinking about angle 2, but angle 1 and angle 3. Let's think about angle 1 and 3. If I call this angle over here angle 4, what can we say about angles 1 and 4? They're congruent because they're what? They're alternate interiors, actually. But you got the idea. They're congruent. 1 and 4 are congruent because of alternate interior angles. And let's say if I call this angle in here 5, then angle 3 and 5 are also congruent by the same theorem, right? From back in chapter 3. So I can substitute angle 4 for angle 1 and angle 3 for angle 5 for angle 3, and I can come up with this idea that the angles of a triangle must equal to 180. So if I know that 180 is going to be equal to the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3, we know that statement's true, right? Make our substitutions, 4 for 1, 5 for 3, then I can also state 180 degrees is going to be equal to the measure of angle 4 plus the measure of angle 2 plus the measure of angle 5. I could set up formally a two-column proof and establish this, which a lot of textbooks will do that, but that's the idea behind it. All right? So that all three angles of a triangle must equal to 180 degrees, no exceptions. All right? That's just how it has to be. All right, let's continue on from here, okay? What is meant by corollary? Add this to your list of definitions for this chapter. Closely related statements associated with theorems that can be easily proved using those theorems. Corollary to the, so we're going to say this, corollary to the angle sum theorem says this: the acute angles of a right triangle are complementary, which means what? What's complementary angles? 180. No, that's supplementary. 90. Equal to 90. 90. That means they must equal to 90 degrees. Okay? Now, we're going to use the theorem that we just proved, 4.1. The sum of the measures of the three angles of a triangle is equal to 180 degrees. So consider right triangle A, B, C. Okay? Consider right triangle A, B, C. Now we know from the triangle angle sum theorem that the measure of angle A plus the measure of angle B plus the measure of angle C is going to be equal to what? What? No. Measure of angle A, B, and C is going to be equal to what number? Of this triangle here. What is the degree measure that those angles have to equal up to? One, no. Well, yeah, I'm sorry, yes. 180. I'm hearing two people at one time. Yeah, 180 degrees. Now, what do we know about angle A? It's 90 degrees. So let's rewrite this equation. 90 plus the measure of angle B plus the measure of angle C. Okay? Now let's subtract 90 from both sides, right? So if we do that, using a little bit of algebra here, right? That's basically the proof here. So that means the measure of angle B plus C, we may not know what the individual measures are, but we know that in a right triangle, these angles have to equal to 90 degrees, correct? Okay. Now, theorem 4.2. Theorem 4.2. The exterior angle theorem says this. The measures of the exterior angle of a triangle is equal to the sum of the measures of the two remote interior angles. Now, what do I mean by that? Any triangle, we'll draw a triangle here, it's sort of scaling, right? If I think of each side of the triangle as being contained within the line, there's a line that contains each one of the sides of this triangle. If I, for example, consider this side right here, okay? Continues on here, right? This line right here will form an angle right here that I'm going to refer to as, we'll call that angle 1, okay? Angle 1 is an exterior angle to the triangle, all right? The two remote interior angles to the triangle, if I call this angles 2, 3, 4 for right now. Angle 1 is my exterior angle. The two remote interior angles are the two non-adjacent angles to it. 2 is an adjacent angle to angle 1, okay? 3 and 4 are non-adjacent. They're referred to as remote interior angles. They must equal to the measure of angle 1, all right? Why? Because I know that the measure of angle 1 plus the measure of angle 2, they form a linear pair, so they've got to be 180, right? I know from the triangle angle theorem that angles 2 plus the measures of angle 3 plus the measures of angle 4 have got to equal to 180 degrees, right? So by simple substitution, I can state that measure of angle 1 must be equal to the measure of angle 3 plus the measure of angle 4, right? That's basically my proof of the exterior angle theorem, that it must be equal to the sum of the measures of what we'll call the two remote interiors, or the two non-adjacent angles. Your book says non-adjacent angles. Most of the books I've ever read refer to these angles, non-adjacent angles, as the remote interiors. Now, what is remote interior depends on what you're talking about as far as exterior angles. If I think about this side of the triangle here, being contained with this line here, right? Then I consider this angle right here. Okay, this one right here. Let's say if we call that angle, let's call that angle 5, okay? Angle 5 is my exterior angle to this triangle. What are the two remote interiors there with respect to angle 5? Angle 2 and 4. So 2 and 4 are remote to 5. Now if I consider the line containing this side of the triangle here, then I can consider this angle right here. I could call that angle 6, for example. And if that angle 6 is going to be, that's my exterior angle, what are my two remote interiors with respect to 6? 2 and 4. Okay? Now, you're going to need to understand this, and if you're listening to music, you're not going to fully get this. And when it comes to trying to figure out how to do the algebra and some of the problems you have to do for your homework, you're going to have some trouble. Okay? I want to go ahead and give you your assignment based on what it is that you're doing here on this, what we just did on the discussion. I'm going to have you guys do problems 1 through 21, okay? Page 182 to 183, 1 through 21, okay? Make that your assignment. We're going to talk about this a little bit more tomorrow. Yes. And then we'll get into the next section if we can. That's what my goals are, okay? All right.